So perfect. Uploading PDF is done. You can see that now we have a chat input and we can chat with our model. I'm gonna first ask a very simple question. For example, let's ask, what is the population of Germany? What is the population of Germany? Okay, that's our answer. Is saying that according to the provided data, Germany has a population of around 80 million, which is completely correct. As you can see, by the estimation of the model, it's around 80 and it's pretty good. I'm gonna also ask a little bit more challenging question. I'm gonna ask which country has the bigger population, United States or Egypt? And the question, let's just ask it. Which country has bigger population? United States or Egypt? Let's just send it. So it's good because we are asking one of the countries from the table and one of the countries from the graph, and we want to make sure that it's parsed both table and image correctly. Okay, it's saying that the United States has a population of 332 million, while Egypt has a population of 104 million. Therefore, the United States has a bigger population than Egypt. So once again, it's correct. It just estimated this as something like 104, and then United States as, which is already written here. It was able to extract all this information correctly and then compare them together, which is amazing. Hey everyone, Nariman here, welcome to my channel. Today we want to use Google's new open source model, which is called Gemma 3, to create a multimodal RAG. If you tried to create RAGs over PDFs before, you know that most of them doesn't only contain text. Many of them have lots of images, lots of graphs, bar charts, pie charts, and also there can be lots of tables in those PDFs. And these images usually contain important informations. But since you could only extract text from it and then pass this to LLM via RAG, you were not able to process them and then ask questions about them when you are using LLM to chat with that PDF. To create multimodal RAGs, you need a model that can understand both text and images. And luckily, right now, thanks to Google, we have a very good one. Gemma 3 was recently released, and as you can see, it's also available on Ollama, and it can understand both text and images. So if you have a look, you can see that it comes in 4 different versions, and you can see some information about it. In the evaluation part, you can see it's a very good model here. There is some benchmarks. And if we want to install it, I'm going to use the 27B version. You need to go to the command line and call Ollama pull Gemma 3 and then 27B. And then you will hit enter and it will pull the model for you. So now let's go over to the code and try to create a RAG with this new model. First of all, let's see what kind of dependencies we need. I'm going to use a Streamlit to create a UI to chat with that PDF. And then I'm going to use LangChain to connect to Ollama and in this specific case, Gemma 3 model and interact with it. There are many dependencies regarding LangChain. And one of the most important dependencies that we are going to use today is unstructured. Unstructured is one of those libraries that helps us to parse PDFs and extract text, image, table from it. To install these dependencies, you need to go to the command line again, and then pip install -r. And notice that I'm already in the directory of my project. And then my requirements.txt, I'm gonna hit enter. And then it will start to install all the dependencies for you. So now that we installed all the dependencies that are required, let's go back to the code. I already created a Python file called multimodal RAG.py. And then I copied the whole code from one of my previous projects, which was RAG on PDFs using DeepSeek. I'm going to explain to you this code very quick, but if you have no idea how RAG works, or you want deeper explanations on this code, I would suggest you watch this video that I'm going to put on top. On that video, I explained in depth how I wrote that code. So in summary, user would come and upload a PDF. We are going to load that PDF, parse it using PDF Plumber, which is another library apart from unstructured that works with PDFs and help you parse it. And then I only extract text from it. If there is any image or table, I'm gonna ignore it. And then I'm gonna split that text, because sometimes PDFs are so big and having a smaller chunks helps with better accuracy using LLMs. And then I'm gonna index them inside the vector store, which means using some embeddings, I'm gonna bring that text into the vector space, and then I'm gonna store that vector inside the vector store. As you can see, we have some embeddings here defined, and also an in-memory vector store that I'm gonna use. So this is the index part, and then we have a simple UI using a Streamlit that user will come and upload the PDF, and then after all this index part is done step by step, there will be a chat box, and the user will type the questions, and we're gonna pass that question to the vector store, and we are retrieving all the similar docs. So these retrieved docs are gonna play the role of the context. We are gonna pass them as well as the user question to LLM, and we have a very long prompt that is saying you are an assistant for question answering. You need to use the provided context to answer the question, because the LLM doesn't know what is in your PDF. You are loading that information for it and pass to the prompt, and then you are asking the LLM to answer your question based on the provided context. So that is what we call a RAG, and that is what we implemented in that video. Again, if you want a better understanding of how this code is working, just go and watch that video before watching this one. And now to add the support for images and tables, we need to work on this part, which we are loading the PDF. Here we were just using PDF Plumber loader, which was ignoring all the images and tables and only keeping the text. We need to change that. So let's remove this part, and then I'm gonna use the partition PDF inside unstructured library. With this method, you will pass the PDF, and then you will get the elements separated, like the text chunks, images, tables, all of them will be separated and passed to you. And you can customize it. You can pass, as you can see, there is lots of parameters here. You can pass them with the values you want and customize how you are loading the PDF. I'm gonna first, of course, pass the file path. We have a PDF loaded in this directory. Also, I'm gonna pass in a strategy. There are a few partition strategies. I'm gonna use the high res, which is like the high resolution, which make possible to extract also images and tables and use OCR. The other parameter is extract images block types. This one. And this one will say to the unstructured, okay, please store on disk these categories. I'm gonna say, for example, image and yeah, maybe table. I guess it's better to be like this. I don't know if it's case sensitive or not. So when unstructured is parsing your PDF, it will give each partition, each element, a category. And here I want to store them somewhere. When it's image or it's table, I want to store the images in this directory that I created here, which is called figures. So the next step would be extract image output there. Yeah, this one. This one now should be this directory that I have here. So let's go and create a new one called figures directory. And I'm gonna call it here figures. And I'm gonna use this to pass it to unstructured. So what does it all mean? All of this. In simple words, we are just passing a PDF to unstructured. We are asking that we want to keep also the images and text, and we are gonna store it somewhere on hard drive. And we are explicitly asking, okay, do it in this directory, please. After all this, it will give us a bunch of elements. I'm gonna call this elements. We don't need these also, so let's just get rid of it. Now let's first extract all the text elements. So I'm gonna say text elements, and then I'm gonna do a list comprehension here for elements in elements if element.category. As I told you, each partition or each element has its own category, not in image and table. So I'm gonna pick up this element, and it also has a field called text. So what I did here was that, okay, if my element is not image or table, just keep the text. So this way, I already extracted all the text in the PDF. The next step would be to also get a text representation of images and tables. How is this possible? Well, we have our Gemma 3 model. I'm just gonna load all the images and tables that are saved here in these figures, and then I'm gonna pass it to our model and ask, okay, describe me what do you see in this picture. And then I'm gonna store that text representation of the image and the table. Let's go ahead and define our embeddings and models with our new model. I'm gonna say Gemma 3 27B. The thing is also, for embeddings, I tried Gemma 3 and it gives me an error that's like, this model doesn't support embedding. So you can use any other embeddings that you want. You can use DeepSeek. You can use, for example, Ollama 3.2. Whatever embedding model you are using, make sure that you pulled it in Ollama before, as I showed you. Like, for example, if I'm gonna use Ollama 3.2, I'm gonna go to the terminal and I'm gonna say Ollama pull Llama 3.2, and I will pull it and I will make sure that it exists in my local machine. Let's go back. So yeah, please be mindful that Gemma 3 doesn't support embeddings for some reasons. And the other stuff looks good. Let's go and create a new method. I'm gonna call it, I don't know, extract text maybe. Again, it's gonna get a file path. Like the other method. Okay, to pass images to a model, in this case Ollama model, you can see that we already have a model here, yeah, Gemma 3. You need to bind that image. So I'm gonna bind images and then file path. I think it should be a list because it's plural. So let's go with this. And this will give you a new model. I'm gonna say model with image context, something like that. And then you can just say invoke this, and I'm gonna ask my model, tell me what do you see in this picture, and that's it. I'm gonna return that. So easily you can get a text representation from your image this way. You bind the image, and then with this model that has this image context, you are asking, tell me what do you see in this image. You can go with much more complicated prompts if this is not going to give you the right answer. I'm just gonna stick with that for our showcase. Okay, now that we have this, here I'm gonna load all the files that are in the figures directory using os.list there. We have figures directory as a variable, so let's just do that. And now one by one I'm gonna call extract text. I'm gonna say extract text, and then this will be the file path, and this is gonna give us the extracted text. That is what I want. I'm gonna add that also to the text elements because it contains all the text like this. Oh, sorry, extracted text. And now we have all the text elements and also text representation of our images. We can just return a huge text, maybe with join. Like I'm gonna say join it with some new lines, these text elements. So we are done with this load PDF. And if you go here, you uploaded the PDF, you loaded the PDF. But here, since we are not returning LangChain documents anymore, I'm gonna just call this text. And then I'm gonna pass this text to a split text. Here it shouldn't be text anymore, so I'm gonna use a split text instead of split documents. And then yeah, here it can be chunked text, and I'm gonna pass this to here. And then index docs can be also add text instead of documents. So other than that, it looks good. I guess we are good to go now that we have a representation of our images, and then we are also adding them to the vector store. as text representation. So yeah, I guess it looks good. Let's go ahead and try it. Let's go to the terminal. We need to call a Streamlit run and then our Python file. Let's run it. Let's go to the browser. So as you can see, we can upload our PDF now. For our showcase, I created a simple one-page PDF. I will show it to you now. So this is just a very simple document that I created myself about population. I'm just saying that this document provides some information about the population of the countries. This paragraph is mainly just saying this. But the key is all the important information are in the table or in the graph. So our RAG can only be useful if it can parse this table properly and also parse this image properly. Other than that, there is not much information that it can give me when I'm chatting with it. There are some countries in the table with their population. There are some countries like Japan, Germany, and Egypt in the graph. And also you can see that like here in the population axis, the populations are not that exact, yeah? So you can see that Japan's population is somewhere around 125, but not exactly. So the model should also somehow be able to estimate this, to understand what is the population of the 3 countries that are in this bar chart. So let's go and upload, and then I'm gonna ask some question about this PDF. I'm gonna just drag it here. You should wait, depends on your local machine power, 1 or 2 minutes at least, even for this one-page PDF, I would say, because it's doing lots of things. It's processing images, it's extracting text, it's chunking text. So let's wait. So perfect. Uploading PDF is done. You can see that now we have a chat input and we can chat with our model. I'm gonna first ask a very simple question. For example, let's ask, what is the population of Germany? What is the population of Germany? Okay, that's our answer. Is saying that according to the provided data, Germany has a population of around 80 million, which is completely correct. As you can see, by the estimation of the model is around 80, and it's pretty good. I'm gonna also ask a little bit more challenging question. I'm gonna ask which country has the bigger population, United States or Egypt? And the question, let's just ask it. Which country has bigger population? United States or Egypt? Let's just send it. So it's good because we are asking one of the countries from the table and one of the countries from the graph, and we want to make sure that it's parsed both table and image correctly. Okay, it's saying that the United States has a population of 332 million, while Egypt has a population of 104 million. Therefore, the United States has a bigger population than Egypt. So once again, it's correct. It just estimated this as something like 104, and then United States as, which is already written here. It was able to extract all this information, correctly and then compare them together, which is amazing. So yeah, that was it, guys. I hope you enjoyed watching this video. Please like it and also subscribe to my channel for more content like this. See you around.